Good morning, students. Today, we are going to begin our module, Algorithms and Flowcharts, which is an important topic in programming and problem solving. Before writing any program in a language such as C, Java, or Python, we first need to plan the solution. Programming is not only about writing code, it is about thinking logically and designing a solution to a problem. To design solutions clearly, we need programmers use some important tools like algorithms and flowchart. An algorithm explains a step-by-step procedure to solve a problem, while a flowchart visually represents those steps using diagrams. These tools help programmers understand the problem clearly, plan the logic before coding. It is going to reduce errors during programming, and it improves problem-solving skills. In this lecture, we will learn what is an algorithm, the characteristics of an algorithm, what is a flowchart, and the symbols used in flowchart with some examples. Now, let us begin with the concept of an algorithm. An algorithm is a step-by-step procedure used to solve a problem or perform a computation. In simple terms, it is a clear sequence of instructions that tells us how to achieve a specific task. An algorithm can be followed by a human, a computer, or any system capable of executable instructions. Let us suppose consider a real life example. Like I want to write an algorithm to make a cup of tea. So what is the first step? You're going to boil the water, add some tea powder. In the next step, step 3, add some sugar and milk. In the next step, you're going to stir it and boil for some time. And then in the last step, you're going to pour it into a cup. This is a step-by-step procedure, which is exactly what an algorithm represents. So, the importance of algorithms in programming is it helps programmers break complex programs into smaller steps. It is mainly used to design efficient solutions and write better programs. In programming, every program is based on an algorithm. Now, let us see some set of steps to be considered a proper algorithm. It must satisfy important characteristics. First one is input. An algorithm may take 0 or more inputs. Inputs are the data values provided to the algorithm so that it can perform calculations or operations. For example, to calculate the sum of numbers, the inputs are what are the inputs? You have to take two numbers, like let us take A and B. Output. An algorithm must produce at least one output. Output means it is a result produced after executing the steps. If we take two input numbers like 5 and 7, the output will be 12. Third one, definiteness. Each step in the algorithm must be clear and unambiguous. Means like every instruction should have only one meaning and should not confuse the reader. For example, like suppose I want to add 5 and 7. Okay, it should be the instructions must be clear that add 5 and 7. You're not supposed to give like add 5 or 6 or 7 like that. Next one is finiteness. An algorithm must end after a finite number of steps. It should not run forever. There must be a starting point and an ending point. For example, if we start, then you are going to take the input, process it, output, and then stop. Next one is the effectiveness. Each step in the algorithm must be simple, basic, and executable. This means that the instruction should be practical and possible to perform. For example, add two numbers is effective, but an instruction like solve world hunger instantly is not a practical for an algorithm. So these are the five characteristics like input, output, definiteness, finiteness, and effectiveness. Now, let us look into the next concept, flowcharts. A flowchart is a graphical representation of an algorithm. Instead of writing steps in text form, a flowchart, it uses symbols and arrows to represent the sequence of operations. This makes it easier to visualize the flow of program. Let us see, like flowcharts help programmers in several ways. In visual understanding, because they provide a visual representation like how a program works. Logic before coding. Programmers can analyze, they are going to analyze and improve the logic before writing any actual code. It acts as a communication tool. Like flowcharts are very easy to understand and can be used to explain program logic to others. Because of this, flowcharts are often called as universal language for program design. Now, we will see the common flowchart symbols. Flowcharts are used as standardized symbols. They are going to use some standardized symbols. Each symbol represents a specific operation. Now, let us discuss the important, like the most common symbols. You can see the oval, start or end points of the program flow. The oval symbol represents the beginning or end of the program, like example, start and stop. This symbol indicates where the program begins and where it is going to finish. Rectangle. It is mainly used for process. The rectangle symbol represents processing steps. These steps perform operations such as calculations. Parallelogram. It is mainly used for input and output. This symbol represents input and output operations. For example, like input is A comma B and displaying sum, all these like for input and output. Diamond, it is for decision making. So this symbol is used for decision making. It is used whether the program must choose between two or more paths. For example, is A greater than B? If the answer is yes, the program follows one path. If it is no, it follows another path. Next one, arrow. That is a flow line. Arrow indicates the direction of proper flow. They show how the steps are connected in the flow chart. Next, when designing a flow chart, we must follow some certain rules to keep the diagram clear and organized. So, when it comes to the first one, start symbol. Every flow chart must begin with start symbol. This shows where the program begins. Next, second one, end symbol. Every flowchart must end with the end or stop symbol. This indicates the completion of the process. Connected arrows. All symbols must be connected using arrow lines to show the direction of flow. Without arrows, the sequence of steps would not be clear. Rule 4. Distinct outcomes in decisions. Like each decision symbol must have at least two possible paths. Like say yes or no, true or false. The next rule is logical flow direction. Flowcharts usually they move either top to bottom or left to right. So the rules, like these are the 5 rules for creating the flowcharts: start, stop, the arrows for the connection, and decision making, and the flowchart moves from top to bottom and not from left or from left to right. Yes, here you can see the symbols, flowchart symbols, the symbols that are used for process. The first one, process. The next one is parallelogram, used for taking input and output. Next one is the decision making, which is used for used to ask a question, like it can be answered in binary, either true or false or yes or no. Next one is the connector, where it allows the flowchart to be drawn without taking any intersecting lines or without any reverse flow. You can see the next one where you're going to define that subprograms or modules. And you can see the oval terminal where it indicates the starting and ending. The flow lines shows the direction of flow. Now, let us see a simple example algorithm. Here, it is like adding two numbers. So the algorithm steps, like in the step one, it starts. Step two, input two numbers, like you're going to take A and B. The third step, calculate sum is equals to A plus B. In the fourth step, you're going to display the sum. And in the fifth step, you're going to write the stop. First, the program starts. Then it asks the user to enter two numbers. After receiving the input, the program performs the addition operation. Finally, it displays the result and stop. So you can see on the right hand side, like we can first is the start and the stop. You can see the oval symbols. Next, for input, you're going to take declare variables n1, n2 and sum. You're going to read the numbers n1 and n2, and after that you're going to add n1 and n2 to sum, and you're going to display the sum and then stop. Now let us see another example involving decision making. So here you can see the algorithm. The first step, you're going to start. Second one, input numbers A and B. Now I'm going to check. Here I'm going to make a decision. If A is greater than B, then largest is equals to A. In the next step, I'm going to write else largest is equals to B. In the fifth step, I'm going to display the largest. And in the sixth step, it is stop. So here, first the program starts and receives two numbers from the user. Then it checks the condition A is greater than B. If the condition is true, the program assigns A as the largest number. Otherwise, it is going to assign B as the largest number. So you can see here, you're going to start the flowchart accepting numbers 1 and 2. Here I'm going to check whether number 1 is greater than number 2. If it is true, it is going to display number 1, else it is going to display number 2, and then finally it stops. Next, we will see the advantages of algorithms. As you know that algorithm, it is a step-by-step representation of a solution to a given problem, which makes it easier to understand. An algorithm uses a definite procedure. It is not independent on any programming language. So it is easy to understand for anyone, even without programming language. Every step in an algorithm has its own logical sequence. So it is very easy to debug. By using algorithm, the problem is broken into small pieces or steps. Hence, it is easier. So it is very easy for the programmer to convert it into an actual program. What are like the disadvantages of algorithms? Algorithms are very time consuming and they are difficult to show. Branching and looping in algorithms. Big tasks are difficult to put in algorithms. Now, we'll see the advantages and disadvantages of a flowchart. Flowcharts are a better way of communicating the logic of the system. They act as a guide for blueprint during program designing. Flowcharts help in debugging process. With the help of flowcharts, programs can be easily analyzed. They provide better documentation. Flowcharts serve as good proper documentation. Then we look into the disadvantages. It is difficult to draw flowcharts for large and complex programs. There is no standard to determine the amount of detail. It is very difficult to modify the flowchart. Making a flowchart is costly. If any changes are done in the software, then the flowchart must be redrawn. So, to conclude today's lecture, algorithms and flowcharts are the fundamental tools in programming. An algorithm provides the logical steps to solve a problem, while a flowchart visually represents those steps using symbols and diagrams. Using algorithms and flowcharts, they are going to help programmers design solutions very clearly, identify the logical errors. They can write better and more organized programs. Before writing programs in C or any language, it is always a good practice to design the algorithm and the flowchart first. This improves both program efficiency and readability. So with this, we can like you'll be having an idea, like a brief idea, like what is an algorithm and what is a flowchart and the difference between an algorithm and a flowchart, its advantages and disadvantages. Thank you.